Hi, today our topic is about partitioning line segment. By definition, partition means to separate or divide. A line segment can be partitioned into smaller segments, which are compared as a ratio. So in this topic, you will be hearing the word ratio. Partition occurs on a line segment that are referred to as a directed segments. A directed segment, by definition, is a segment that has a distance, meaning there's a length, and of course, there's a direction. It is important to understand that a directed line segment has a starting point. We somewhat refer this starting point as the initial point. Normally, as an example, when we are working with segment AB, it does not matter whether we consider point A first or point B first. However, if AB is a directed segment, we will be starting at point A as the starting point or the initial point and moving it in the direction of point B. This direction will be used to clarify the location of the partition ratio on the segment. Example, if I have here segment AB, so I'm going to draw a segment. Segment AB, just give me a second here. And let's try to use, and then this one will be solid. So let us say I have here segment AB. And let us say that segment AB is being partitioned with a ratio of 2:3. Okay. The ratio implies a starting point at point A. The ratio of 2:3 indicates that the segment will be actually be divided into 5 equal parts or 5 equal sections. If P is the partition point, it will be located 2 of the equal section away from A and 3 equal section away from B. So consequently, P will be closer to A. Okay, so I'm going to mark this as A. This is point A and point B. Okay, so as what I've said, P will be closer to A and it will be to B. Okay, since A is the initial point, okay, this A here is your initial point. Notice how in this example, describe the situation starts from point A. So let's start with point A. If this is point A, I'm going to move A, maybe just do partition. So it's twice. Let's say that's 1 and then 2. So this will be point. Just imagine that it was partitioned equally, and then from there, if you count 3 times, this is 1, 2, 3. So this is 2 times, and then this one will be 3 units. So 2 units and 3 units. So if you will convert your ratio into fraction, you just get your 2 as your numerator and then add the 2 numbers, which will become your denominator. Therefore, if you look into this, so that's 1, 2, 3, 4, 5. So it was partitioned 2/5. So the 5 will be as a whole, and then you partitioned your segment into 2 equal parts. But your A to P is 2 units and P to B is 3 units. Okay, so let's proceed with the first example on the partitioning line segment that is that requires you to graph, or I'm going to show you to graph it. The question there is Mr. Is it does a partitioning line segment requires graphing? Somewhat, I would say no, because partitioning line segment, I'm just showing you to graph it. It's because I want you to visualize the concept of partitioning line segment. All right. So on this example, given the point A, -1, 2, with the coordinate -1, 2, and B is located at 7, 8. Find the coordinate of point P on directed line segment AB that partitions AB in the ratio 1:3. First is you have to graph the points. So this is your, I'm going to graph the points. This is my x1, and this is y1. This is x2, and then we have y2 here. So I'm going to graph point A, which is -1, 2. So -1 and then +2. This is my point A. Okay, don't forget to name your points. And then we have 7 and then 8. Now this is your point B, right? Now you are going to draw a line segment on this. So I'm going to draw now. So draw a line segment from here. Maybe I'm going to use blue ink from here to there. Oh, sorry, I need to be precise on this. So from point 2, again, I'm just being precise. Sorry, guys. And accurate as possible so you can see. All right, so this is now your directed line segment. Now we are going to do 2 steps to find the coordinate of point P. First step is we are going to solve for the horizontal change. Horizontal change, basically, horizontal change is your x, the change in x, okay? And then the next one will be the vertical change, which is your change in y. So this is the y, all right? So we are going to use, okay, to solve this, we are going to use your ratio, and then we multiply that by the difference between your x2 minus x1. The same with the vertical ratio. So you have get the ratio and then multiply that by the change of y's. All right. So what is the ratio? Of course, you cannot multiply 1:3 with this number. So what I'm going to do is I will convert this 1:3 into fraction. That's what I've said. Keep your 1 as your numerator, and then 3 plus 1, which is 4, that's your denominator. So meaning it's the whole, you're dividing it, you're dividing your line segment into 4 parts, or the it's not 4 parts, it will be the whole line segment measures 4, and then you have to divide in the ratio of 1:3. So 1 unit, A is 1 unit away from P, and P is 3 units away from 3 units away from your B. So let's start with this. The ratio is 1/4. Okay, I'm going to change ink. So the ratio is 1/4. And then your x2, which is 7, minus x1, which is -1. So I'm going to put that in parentheses so you can see this is -1, right? So 7 minus -1, that is 7 plus 1, which is 8. So 1/4 times 8, which will give us now 2. I'm going to box this one because we will need this one on the next step. Second is your vertical change. The vertical change will be again the ratio, which is 1/4, the value of y2, which is 8, minus the value of y1, which is 2. Now we have 1/4, which is 8 minus 2, which is 6. And then 6, divide this one by 4, or you can actually simplify this because 6/4 will be simplified as 3/2 as a fraction. Okay. Now we will be using this horizontal and vertical changes on step 2. I'm going to use blue ink. So on your step 2, because it says there it's a direct line segment AB, so your starting point will be A. I'm going to get the ordered pair on my A, which is -1 and 2. The value of x is -1 and the value of y is 2. And then I'm going to use your 2, your 3/2, and my A to find the value of P. Mister, how are we going to do that? The value of P, which is a point. Of course, if it is a point, there is a value of x and there's a value of y. So I'm going to get the horizontal change, which is 2. And then I'm going to subtract. It's always subtraction on this is step 2. Subtract that with the x value on your A, which is -1. All right. And then I'll put a comma. This indicates that I'm going to move on the value of y. So 2 minus -1, that's the value of x. Now I'm going to use 3/2 for the value of y. So 3/2 minus the value of y on your A, which is 2. All right? Or, I'm sorry, we have to add. It's not, we have to add, sorry. I'm going to add both by, so I'm going to add, there you go, sorry for that. Sorry for the confusion. There you go. So the answer here will be the value of x, and then the answer here will be the value of y, right? So your P now will be, you have 2 plus -1, which will give me 1, and then comma, that's the value of x now, and then 3/2 plus 2 will give me 7/2. I'll repeat, you have to add. I'm sorry for that confusion there. You have to add. Now this is now your point P. Okay, your point P partitioned your AB in a ratio of 1:3. So I'm going to graph point P. Maybe I'll be using what color? Maybe red. So 1, that's 1, and then 1, 2, 3, and then 0.5, maybe it's here. So this is now your point P. So if you take a look at this one, okay, from here that's 1 and 2, from here that's 2, and then here is 1.5. Okay, from B going down here, this will be 6 units, and from A, I'll be using maybe green. From A to here, you got 8. Okay, so that is, this corresponds to that. So 2 corresponds to 8. So 2 over 8, which will give you 1/4 or 0.25, right? Now the same with this, 1.5 corresponds to 6. So 1.5 over 6, if you are going to divide that, it will give you still 1.25. So meaning we partition the segment into the given ratio correctly, which is 1:3. All right. Next example is we have this. Let's see. Oh, it's a multiple choice. I think this is an example from a given test. I think it's on your SAT test. I get this one from your SAT test. So you have to we have to graph. So x1, y1. This is x2 and then y2. I'm going to graph 2, -1, 2, -1. This will be your A or P, sorry. This is P. And then -9 down, -9, -6. This is Q. And I'm going to connect this. Maybe I'll use blue color. So I'm trying to be accurate as much as possible. All right, so this is now your line segment P and Q. What are the coordinates of the directed line segment? PQ, so we start from PQ, that partitions PQ in the ratio 3:2. So 3:2 will be, if I'm going to convert that, 3:2 will be 3/5 as a fraction. So again, horizontal change, okay, horizontal change. So your horizontal change would be 3/5. That's the ratio here. And then x1 or x2 is -9 minus x1, which is 2. That's 3/5. 9 minus 2, it's -11. This will give us -33/5. I'll box this one because we will be using that. And then for vertical change, your vertical change will be 3/5. And then we have -6 minus -1 will give us 3/5. -6 minus 1, that is -6 plus 1, will give me -5. And 3/5 minus times -5, I'm sorry, will give us -3. Right? We'll be using that again. Now on step 2, all right, step 2 is we're now going to solve for the point that partitions the given segment into the ratio 3:2, meaning the whole segment measures 5, and then we have to partition that into 2 parts, wherein the first part is 3 units away, and then the second part will be 2 units away from the partition point. So step 2 will be, we have the point, we have 33/5 plus 2, right? And then comma, we also have -3 plus P is -1. -1. So 33, -33 over 5, this will give us -23 over 5. And this is -4. So this is now the partition point. So it would be, if I'm going to highlight the answer, it would be A. So the answer would be A on this situation. So if you're going to graph this, -23 over 5, it's like 6 point negative. This is negative 8.2. 8.2, and then you go -4. So we have negative, sorry about that, -23 over 5 will be 4.6, -4.6, and then -4, so it's like somewhere here. Okay, this is the partition now of the point. All right, next example. So find the coordinate of P so that P partitions the segment AB in the ratio 5:1. So 5:1, that is 5 over 6. If A is 2, 4, so A is 2, 4, and B is 8, 10. 8, 10. So we are going to find the coordinate of P. So I'm going to connect this one using a line segment. Okay. Next is we get the horizontal change. So your horizontal change would be 5 over 6, multiply that by 8 minus 2. Okay. So 5 over 6 will be 6. This will be cancelled. Therefore, the horizontal change will be 5 using the ratio 2. The vertical change would be 5 over 6. Multiply that by 10 minus 2. Minus 4, sorry. 10 minus 4, which is 5 over 6 times 6. It's interesting. This will be cancelled out because it will still give you 30 divided by 6, which will be 5. So we'll be using both a 5 for your first point. So the point, partition the segment AB in the ratio of 5. So your A, I'm going to use blue. A is 2, 4. So I'm going to use that. So your point P now is equal to 5 minus 2, comma, 5 minus 4. So your point P will be 5 minus 2, which is 3. And then we have, or 5, we're not subtracting, sorry, I get confused with the, we're not subtracting, we are adding on the second, sorry for that. So we are going to add 5 plus 2, which is 7, and 5 plus 4, which is 9. So this is 7, 9. I'm sorry. I got messed up with the subtraction in the first part, and then the second part is add. So the first part is you have to subtract, and the second part is you have to add. So the point now will be 7, 9. So 7 is here, then 9 will be in here. So as you can see, that is 1, 2, 3, 4, 5. Okay, that's 5. So, and then you have this one, it's 1. So 5. This part is divided into 5 units away from P, and then this is 1 unit away from P. So this is your point A, and point B. So that is how you partition. um, with um, with a segment, right? So what are we going to do is I'm going to summarize. When we say we have to partition, make sure that you convert your ratio into fraction first. But if it is in a fraction already, it's good to go. And then when we are partitioning line segment, always remember to go back and look at the ratio. And then when you check it, the way I counted it on the graph, and I think that's it. If you have any question, feel free to email me, and feel free to join us during Monday, Tuesday, Wednesday, and Thursday during small group from 9:15 to 9:45. The link for the Zoom on that is on our homepage. Thank you, and have a good day.